Hello. Let's do the last one. The last one is get nth word, where you give it a string and a word number, and it will return that word in your original string. So if I'm getting the fourth word, that would be 1, 2, 3, 4. That would be the word potato. Or if I said word number 1, that would be hello. Okay, so like we did before, let's try and come up with some pseudocode. I want to bring out a contrast, two different ways people tend to think about problems like this. So you can think about process, like what are a sequence of steps that would get me the thing I want? And an example of that, well, here, let me brainstorm sort of a process-based approach. So I'm thinking, all right, if I want to get, let's go back to word 4. So if I want to get word 4, it's like I could start looping forwards, and I have to figure out some way of figuring out which word I'm in. So I guess I could count spaces as I'm going along. And then once I had the right number of spaces where I knew I was in word 4, then I could start adding the letters one at a time to my outgoing string until I reach another space. So it would be something like this. Loop from 0 to the end. And then I would have a space counter, which starts at 0 because I haven't seen any spaces. And then I'd say if letter at I is a space, then space counter plus plus. And then okay, so let's see, how could I figure out if I was in word 4? So word 4, 1, 2, 3, 4, would be if I'd already seen 3 spaces, then I'm in word 4. So if space counter is equal to word num minus 1. Because if I'm at word 4, word num is 4, but I want to know if I'm currently at 3 spaces, then I want to add current letter to outgoing string. And then I guess I could say else if space counter is greater than, or let's say if it's equal to word num, then I could just return right away. So that would be sort of a process-based approach. I tried to think kind of one step at a time what would get me there. We can come back and implement this in a second. It's almost all implemented, and this does seem like a pretty straightforward approach. But I wanted to contrast that with a different way of thinking about the problem. A different way of thinking about the problem is about the structure of the problem itself rather than steps that would get me a solution. So if I think about the structure of the problem itself, one way of doing that is thinking about what pieces of information would make the problem trivially easy to solve. So I'm trying to get the fourth word. So if I knew the index of the third space and the fourth space, then I could get the word in between. And that's sort of like using like our substring pattern. Like we know what substring can do. So what if I have pseudocode that works like this? And it's not even pseudocode. This could be real code, just programming by intention. So first space index would be find nth space in the string, and the space I want to find is word num minus 1. And so again, like instead of variables, let's think in terms of a specific example. So if word num is 4, here I'm saying find the nth space where n is 3. So in other words, I want to find the third space and save it. And then I want to find the fourth space. Maybe instead of first and second, let's say start and end. So start space and end space. So the start space is going to be the third space. The end space is going to be the fourth space. And then I can literally just return string.substring starting at the start space plus 1 and ending at the end space. So this certainly looks like a very straightforward solution. It's like find this space, find that space, return the bit in between. A lot of the complexity is hidden because how are we going to find the nth space? And remember from the last video, it's also helpful to think about possible edge cases. So what would happen if I tried to do this with the first word? with the first word, I'd be trying to find the nth space of 0, but there is no 0 space, and so that would just immediately fail. So there's some edge cases to consider with this approach. So now let's jump back to the other solution. I want to implement all the solutions because it's a helpful exercise to think through lots of different ways to do things and actually make sure you can do them all. But that said, let's go back to the original solution now and actually program it. So my space counter is going to be an int. If I'm looping through the string, I can use a for loop for that. So start at the beginning, end at string.length. So if the letter at I is a space, so let's get out the letter. String letter equals string.substring I plus 1. And so if it's a space, so if letter dot equals space, then I'll increase the space counter. If space counter is that one, then, oh, we need an output string. So here I'll say output plus equals letter. Otherwise, let's return output. All right, so I think I'm done. But remember, we have to think through all the possible edge cases. And one thing I'm noticing is here it says missing return statement, because right now my only return statement is here. So why is the return statement missing? It's like the computer thinks that maybe it's not possible for me to reach this return statement. So when would that happen? It's like, for example, if the string's length were 0, then I would never even enter the for loop. So if I would never enter the for loop, let's return empty string. When else might this happen? Let's think of other edge cases. So edge cases would happen like at the very beginning or like at extreme values. So let's think, would this work for the first word? Would this work for the last word? So for the first word, space counter starts at 0. I'm looping through. Sorry, I want to try and fix my formatting. Okay, so I'm looping through. I'm not finding a letter. Space counter does equal 1 minus 1. Space counter does equal 0. So even though I haven't seen a space yet, just right away I'm going to start adding in characters, which is what I'd want to do because this is actually the first word. So I'm adding characters. Eventually, I'm going to get to this index where the space is. I'm going to get the space. I'm going to detect that it's a space. We'll increase the space counter. Now this isn't true anymore, and I'm going to return it. So it seems like that's going to work. We could verify that it's going to work since we're on the computer. Let's do that. Okay, so that seems to have worked. Let's think about the last word. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So what if word num is 9? Let's think it through. So we're looping through all the characters. Every time we see a space, we're increasing space counter. So I'm imagining looping through, and so space counter is going to be 1, and then 2, and then 3, and then 4, and then 5, and then 6, and then 7, and then 8. So now as soon as it's 8, so one thing I'm noticing is that as soon as it's 8, I'm immediately going to add in the letter. But the letter that I'm on right now is space. And I don't necessarily want to add a space to the beginning of my thing. So I'm going to make this an else if. And the reason why I want to make it an else if is it's like one of these three things needs to happen every loop. Either I've seen a space, in which case I'm done and I'm going on to the next letter, or I'm currently inside the word that I want, in which case I'll add the letter and move on to the next letter, or I've seen the next space, So I'm outside the word I want, in which case I'll return. So an if-else chain is specially designed for the circumstance where you want exactly one of these possible things to happen each time you hit that block. Okay, so all right, so we caught that bug. So where was I? All right, so we just found another space. So now space counter is 8. Because we just increased space counter, now we'll go to the next letter. So the next letter is this D. Now that it's a D, space counter does equal word num minus 1. And so we'll add the letters. But you know what's going to happen? It's eventually, we're never going to find another space because there's not a space at the end of the string. So we're going to keep going, adding letters. But I'll never find another space. Instead, we'll just run out of letters and the for loop will exit. But now we'll return empty string. But we shouldn't return empty string because we've gone to all the trouble of putting all the letters into output. So let's put output here. And that doesn't mess up our original empty string here, because remember, the reason we put empty string here originally was, what if the length of the input string is 0? If the length of the input string is 0, we'll just immediately return output, but output is already initialized to be the empty string. So I think that works. So let's go ahead and make sure that's going to give us the last word. And then we'll think through the case, what should happen if word num is outside the valid range? Doing, okay, so that worked. All right, so I think if word num is like -2 or something, it should just return empty string instead of crashing. Let's think through what it's going to do. So word num's -2. I'll be looping through the things. I'll find some spaces, but space counter is never going to be equal to word num -1 because word num -1 is always too small. So it's like I'll never add anything to my output string, and then eventually I'll return the output, which should just be the empty string. So I think this isn't going to crash. I think this is just going to work. And it does. Okay, what if we give a number that's too large, like 10? I think for the same reason, this is just going to work. Because we'll never, like space counter will never become large enough that we start adding things. Okay, great. So it handles those edge cases already. So you can see you might have thought we were done when we translated the pseudocode into actual code. But that was like 5 minutes ago or 8 minutes ago. So we spent quite a lot of time thinking through the possible edge cases. And it turns out we handled most of them already, but there was one bug already. So this is a normal process when you finish programming a chunk of code, is you made a plan, you implemented your plan, but then you stop and you think, you like go through it again and again, looking at expected inputs, looking at unexpected inputs or edge cases as a way of verifying for yourself that it actually is going to do the thing that you originally planned it to do. All right, let's do it all over again with the other approach. And again, this is a great way to practice. If you're in like school mode, it's often about, can I answer the question? And if you answered the question, like, great, you're done. But you know, if you're learning to program, it's maybe better to think about it not in terms of like, did I get a working solution, but have I learned as much as I can from this situation? And so you could really spend, you know, a full hour, a full 2 hours with one problem, like really working it to make sure that you've understood as much as you can from the situation. So this pseudocode, I'm going to find the nth space, or rather I'm going to find the n-1st space and the nth space. So I'm finding the spaces on either side of the word that I want, and then I'm going to return the amount that's in between. So let's implement our find nth space method. So how are we going to find the nth space? There's two patterns available, and maybe based on the solution that we just did, the pattern that you're thinking of now is, let's just use a for loop, and we'll loop through one letter at a time, and whenever we get to a space, we'll add to a counter, and if we get to the nth space, then we'll return the index where we saw it. And that would actually be a really great approach. If I hadn't just primed you with that particular approach, you might have thought about using index of, because very frequently when we're searching for something, we're using index of. So I've seen a lot of students try and use a while loop here, which isn't a bad idea, but as you're about to see, it's a little fiddly in the details. So it's sort of like, let's do a pseudocode version first. So while there's another space to find, or let's do find index of first space. And now, while there's another space to find after the most recent space we found, right? So if there's like a next space after the current space, then let's find the index of the next space. And the whole point here is we're trying to find the index of a particular space. So let's have a space counter set to 1, because we already found the index of the first space. And so if there's another space to find, let's add to the counter. But when do we exit? We'd want to exit when we actually found the right thing. So I guess you could put an if statement in here. So if space counter equals the thing we want, then return the index that we found the space at. We have to think about what would happen if this is never true. What happens if we keep adding to the space counter, but the while loop exits before it gets to the number we want? That would be a situation where maybe the input string only has 3 spaces, but we're looking for the 5th space. In that case, we're going to add up as we see spaces, but then eventually there's not going to be another space to find. We still haven't hit the number we're looking for. So in that case, we should return -1 as a way of signaling that there is no index for the particular space number that we've requested. So this seems like an okay pseudocode. Let's do it. So current space index equals string dot index of space, and then let's just handle another edge case right away. So if string dot contains space, so if the string doesn't contain any spaces, then let's just return -1 right away, because there aren't any indices to find because there are no spaces. Okay, so now we're going to find the first space, and it's guaranteed to exist, because if it didn't exist, we would have exited already. So now I'll set my space count to 1, because we've already found 1 space. So now we'll do our while loop. While there's another space to find. Okay, how will we know if there's another space to find? Let's try and find it. So string dot index of space, but starting at the current space index plus 1. And so that will start after the space we've already found, but we're going to try and find another one. If we don't find one, so in other words, if there isn't another space to find, index of will return -1. So as long as it's not equal to -1, that must mean that there's an index there that we actually found a space at. And so it's safe to go into the while loop. So here, let's set current space index to be the index of the next space. And let's increment the count. And then we'll say if the count equals n, then let's return current space index. Okay, I think this is going to work. Let's give it a try. So rather than just run it, I'm going to set a breakpoint here, because I actually want to test my find nth space method, and I want to watch it do what it's supposed to do here. So I'm going to set word num to 5. Let's run it in debug mode. All right, so now I'm paused on this line. I'm going to hit this step over button. And so now it says start space, the index is at 21. Let's look at my string. Is it going to tell me my indices? Probably not. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, which is right before head. And so that really is the 4th space, the one we were looking for. the next one should be 22, 23, 24, 25, 26. The next one should be 26, and indeed it is. And so we get the substring, and now word is head the way that it should have been, and we're done. Okay, so that seems like it worked great. Let's check edge cases again. So if word is 1, think about what's going to happen. We're going to ask to find the nth space, which is 0. We're going to find the 0th space. And what's this going to do if we ask to find the 0th space? The string definitely contains spaces, so it's not going to exit right away. Count will start at 1, and we'll loop through the whole string adding to count, but count is never going to equal n because n is 0, and count already starts larger than 0 and only goes up from there. So we'll end up returning -1 in the end because we'll never hit this return statement. And so the starting space will be -1, and then the substring will go from 0, which is where we'd want. Wow, so that actually is going to work out, I think. Let's try it. Am I running it? Yeah, okay. All right, it didn't work out. So what's happened? Here, substring, start space +1 and end space. So I wonder, oh, right, because word num is 0. So here, it's actually -1. So 0 would have worked. Okay, so it's, I counted wrong. I was off by 1. All right, so we know that it works for all these middle words, but it's not working for the beginning word. And the reason it's not working for the beginning word is because there isn't an initial space. If there was an initial space, then it would be like the beginning word would be sort of like a middle word. So here's like a cheap way to do this. String equals space plus string plus space. Let's add artificial spaces at the beginning and the end. Oh, it still didn't work. Why didn't my awesome trick work? Okay, let's think it through. All right, so I want word 1. The first thing that we do is insert a space here. So I want to find space 0 and space 1. So why isn't it doing that? Word num is 1. So I'm going to try and find space 0. Oh, it's really, I shouldn't have made such a joke about off by 1. It's really off by 1. So I'm so used to thinking about 0 indexing. You heard what I said a second ago. I said this is space 0. But we've been referring to this as word 1, which is sort of what you would expect from like regular English language. This is the first word, not the 0th word. But because I was thinking that way, my get nth space method is treating this as the first space. So my find nth space method starts out with a count of 1 because it's like counting how many spaces have I seen. But here I'm trying to give it 0 as the first space I want. So I think I'm off by 1. So I think all I need to do is this word num +1 like this. And actually in that case, maybe I don't, well, yeah, all right. So let's try it. I think this is going to work now. Okay, still not working. Perfect time for debugging. Let's add a breakpoint. All right, makes sense. Let's take a step. Oh, so start space is -1. So that was not expected. I wonder why. So let's run it again in debug mode, and instead of stepping over find nth space, I want to step into it. All right, let's step into it. Cool. We find the index of the first space. The count is 1. N should be 1, which it is. You can see right here. So now count is 1. Oh, I find a count right away. Oh. So because count started at 1, I don't want, all right, another off by 1 bug. So because count started at 1, if n equals 1, I'm done even before I go into the while loop. So this is like a little bit ugly, but so if count equals n, then return current space index. Okay, so that's fixed that bug, we hope. Oh, programming. Let's do it again. So now the start space is 0, which it should be because that's the first space. Let's take another step. End space is 1, but why would end space be 1? Oh, is it because I inserted 2? Oh, it's because it started with a space and I inserted another space, and so it returned the empty string before the initial 2 spaces. So we're going to deal, yeah, so let's run it again. So it really is working as long as we're assuming that our string doesn't start with a space or end with a space, and assuming that there's only a single space separating all the words. Okay, so now we're really getting hello. That works. For word 2, we should be getting there. That works. For word 9, we should be getting doing. For word 10, it shouldn't crash, hopefully. It's definitely going to crash. Right, going to crash. So I think what we want to do, I don't know, my gut feeling is if we wrote this correctly, it's going to return -1 if there is no space that corresponds to the one that we're looking for. So I kind of want to say if start space is -1 or end space is -1, then return empty string. But I'm seeing that the index that I'm accessing is -43, which I think I should never be accessing. So that feels like maybe my gut feeling about this is wrong. Okay, no, that did fix the problem. Okay, great. So this solution felt conceptually simplest to me at the beginning. It was like find the space before, find the space after, return what's in between. But again, there was a lot of detail with the edge cases. There were a lot of things that might go wrong. And all this business with the while loop also is a little bit fiddly to work out. Let's try and replace this method with the other version that we thought about. So space count is 0. Let's do a for loop going from 0 up to string.length. If, let's get a letter, string.substring ii plus 1. So now if letter equals space, then we'll do space count plus plus. And if space count equals the space count we're looking for, then we'll return I, which is the index of the space that we just saw. So this feels to me like an approach that requires less thinking than the while loop did. It's like I'm really just checking each letter and maintaining a count. Let's make sure we're not going to be off by 1 here. Okay, I think that's okay. All right, so the rest of this can stay the way it was because we just rewrote the inside of the find nth space method. So let's now see if it still works. Let's start with word 2. Word 2 returns there, which is what we wanted to. Let's get word 1. Okay, so that seems to be working. So this video was a long video, but it's because it wasn't just about solving the problem. It was about comparing different solution approaches, thinking about a sequential process versus the structure of how you could break your problem into smaller pieces. So if we could just find the nth space, then our problem is trivial. And then in both cases, we saw that even after you write the solution, you want to think about unexpected inputs and kind of think your way through those scenarios. Okay, let's do a second video where we try and generalize these approaches and try and make it work no matter how many spaces there are at the beginning or end, and no matter how many spaces there are separating the words.